we go. Okay, so here is section 4.3 on logarithmic functions. Essential questions for today are: one, what is a logarithmic function? Two, how do I graph inverse function? And three, how do I graph a logarithmic function? So 2 and 3 are basically the same because the logarithmic function is an inverse to the exponential function, right? So here we go. All right, so a logarithmic function is the inverse to an exponential function. So if your exponential function is 2 to the y equals 2 to the x power, then the inverse of it, remember how to get the inverse is we swap out, or we switch places of the x and the y. So the inverse is x equals 2 to the y power, right? And then how we get the inverse is we solve for y. But since the y here is the exponent, right, we got to introduce another function, which is log function. Okay, so that's how you would write it. Y equals log base 2 of x. And this is exactly the same as this guy. Okay, so how we figure this out is I say Tarzan and Jane. Okay, follow me now. Okay, stay with me. Imagine that the base of 2 is Tarzan. Okay, Tarzan, he wakes up, he goes and he puts Jane, Y, on his back. So 2 to the y power, right, equals, and he comes back home, x. Okay, so it equals x. So then that's just one way to kind of know how to work these logarithmic functions. Okay, when the numbers do get bigger, more complicated, remember Tarzan and Jane. All right. But yeah, again, the big picture is this log function is the same, exact same as this. So when we are talking about graphing, right, just like how we swapped out the x and the y, we are going to swap out the x and the y here. Okay. So if we're graphing log base 2 of x, yes.
But can you go back to the other slide? So if you had like x is equal to log base 2 of y, would that be equal to the exponential function?
Yes. Yes. Okay. So this is the graph of log base 2 of x. Okay. And how we put the XY chart together, let's quickly just graph y equals 2 to the x power. Okay, not graph, but then come up with the tables of values. So x and y, I'm not going to do 3 through -4, but I will do -2, -1, 0, 1, and 2. And we did this in our previous lesson, right? Where -2, 2 to the -2 power is 1 over 4. 2 to the -1 power is 1/2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4, right? Yeah. And what the log function did was now my y table of values, right? My y column just became my x column. And my x column here with 2 to the x power just became my y column. You guys see that? Yeah. Just pick 1 point, 0, comma 1. That became 1, comma 0. Okay. Picking 1, comma 2. In my inverse or in my log function, it's going to be 2, comma 1. Okay. Negative 2, comma 1/4. 1/4 in this table of values is 2 to the negative 2 power, is right here. Yeah. So there's just 3 examples of where your x and your y of your exponential just flipped. Okay. So if you're ever confused on how to figure out how to graph log base 2 of x, use Tarzan and Jane, right? This is 2 to the y power equals x. So it would be easier to plug in values for y to get your x values. Okay? So this is the graph, and your what they didn't put on here is your asymptote. Your asymptote line, or the fence that this graph can never, ever cross, is right there. Is your y-axis, or x equals 0. Okay? And then it'll just be like a curve that's going towards your asymptote. Okay? So here your domain will be zero to infinity, whereas it cannot equal 0. All right? And your range then would just be negative infinity to positive infinity. Okay? Notice that your domain and range also flipped. Okay? Meaning here, in terms of exponential function, your domain was all real numbers, or negative infinity to positive infinity, and your range became 0 to infinity. They just flipped as well, right? Yeah. So your range here became your domain, and your domain here became your range. Yeah, it's all about the flipping. Okay, x and y's flip, domain and range flips. All right. Questions on that? Yeah. 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 So then if I kind of makeshift graph y equals 2x, and you guys want to see the inverse of that, it would be 0, comma 1, 1, comma 2, negative 1. I'm going to put negative 1 here, negative 1, comma 1/2, right? And then it will be a function that looks somewhat like this. Yeah, with your asymptote being here. Okay? That's your asymptote line. Okay?
So, the red line is gonna be the first function, and then the green is gonna be the inverse of it.
Yeah.
And with the inverse, the domain is 0 to infinity.
The log function, the red function is 0 to infinity. Yes, the domain is. And your range is all real numbers.
So we started with those on the right, domain range. You started them, and then when you do your inverse, you're just switching them.
Yeah. Yep. Okay. But this green graph here, y equals 2x, that's your previous lesson, right? And now we're taking the inverse of it, which is the logarithmic function. Okay. All right. So here is some general rules, right? The properties of logs, and I put this up here again, that this does equal this. Okay? So log base A of 1 equals 0 all the time. Because if I use that rule of Tarzan and Jane, right? A is Tarzan, and it goes around, picks up 0. A to the 0 power picks up Jane, equals 1. Anything to the 0 power equals 1, right? So any base of 1 will always equal 0. Okay? If you have a log base that's equal to the number, like log base A of A, log base 3 of 3, log base 4 of 4, log base whatever number of whatever number, exactly the same, always going to equal 1, right? And you can verify it by using Tarzan and Jane. Okay, for number 2, it would be A to the first power, right? Picks up Jane, comes back home, equals A. Yeah, A to the first power will always equal A, right? Regardless of whatever value you put in for A. Okay? Log base A of A to the X power, number 3, is equal to X. Okay? Yes, because if I Tarzan and Jane this, A to the X power equals A to the X power. Yes, they do. All right. A to the log base of A equals X. Now, this one, think backwards, Tarzan and Jane. Because it's an exponential function, right? Number 5 or number 4. Yeah. A to the log base A of X power. Right? That's an exponential function. So if you think backwards and go log base whatever of whatever blank equals blank, right? Tarzan and Jane this. Okay, this is Tarzan. This first blank on the bottom here is your base, and your base here is A. So log base A of what's my Jane? It's the power. Log base A of X equals X. Yeah, that's true. Log base A of X equals X. Log base A of X, right? They both equal each other, correct? That makes sense? So whenever you see an exponent and you want to turn it into a logarithm, and we're going to do this next time we meet, think backwards, Tarzan and Jane. If you have a log and you want to turn it into an exponent, exponential function, then just use Tarzan and Jane. Okay? All right. So those are the rules. Here are some just common bases that we use in terms of your calculator. If you look at your calculator, you see the log button. Yeah. Let me show it to you guys like this. Hold on for a second. There we go. There we go. You guys see the log button here? Yeah. There's no base here, right? And right above it is 10 to the X power. If you guys don't know, the calculator is set up in a way where the button and the function that's above the button works as inverses of each other. Okay, so log is the inverse of 10 to the X power. So my base here for log has to be 10. Yeah. So that's why we have a common base here of log of X equals log base 10 of X. Okay. And the natural log E, right? ln, this button here. Oh, you guys don't see that. I moved it. This button here, ln, is the same or inverse of ln is e to the x power. Okay? The reason why that is ln is just log base e. Okay? This rule right here. Oops. This rule right here. All right? So just know that they are inverses of each other. Okay? So here's some properties that we know that we already did, right? But just in natural log form. Okay, going really quick. ln of 1 equals 0. Whenever you see ln and you're confused, turn ln into log base e of 1 equals 0. Well, if you get Tarzan, flip it around, right? Picks up Jane, e to the 0 power equals 1. Yes, anything to the 0 power equals 1, right? ln of e equals 1. Well, ln of e is log e of e equals 1. Yes, e to the first power equals 1. Correct. Yeah, that's rule number 2. Rule number 3, ln of e to the x power equals x. Well, ln equals log base e of e to the x equals x. Get Tarzan, picks up Jane, e to the x power equals e to the x power. Yes, that's true. Okay. And in this one, using the backwards Tarzan and Jane, so log base blank of blank equals blank, right? Thinking Tarzan and Jane, the base here is Tarzan, E. The Jane here is what it equals to, ln of x equals x. Log base E is just ln, right? So I can rewrite this as ln of x equals ln of x. Correct. Yeah, true. Okay, so just maneuvering between log base E and ln, or even logs versus exponentials. That's what we're doing here. Okay, we're just maneuvering between the function and its inverse. Okay. And that's it for today, class. And the law of logarithms and all the rules of logarithms is what's coming up. All right. And that's all the lesson for today. Thank you very much. And I will see you on the next one.